Okay, so a
Sir,
module
recording
provides a
hasn't started, has
template.
it?
Recording is already started. Recording is already started. Okay.
Okay, sir. Thank you.
So a module provides a template from which you can create actual objects. It provides a template from which you can create actual objects. Okay, so when a module is invoked, okay, so now there's a difference between module invocation and function calling. There's a difference between function calling in C, C++ and module invocation in C, C++. Okay, so now I will have, so what is a module invocation? Module invocation. So when a module is invoked, Verilog creates a unique object from the template, a unique object. Each object has its own name, variable, parameters, and IO interface. I will explain this with an example. Okay, so the process of creating objects from a module template is called instantiation, and the objects are called instances. The objects are called instances. So you can instantiate a module template from another module. Also, you can create a module from that. So now this is an example of a 4-bit adder. We already did it. Okay. So if you look at this example, full add. What is full add? Can you let me know what is full add?
Full adder.
Full adder.
No, full add. If you look at the code, what is full add? What is this? It is name of what? It is the name of what?
Module.
Name of module. It's module. Name of the module. And what is my add one? What is my add one?
Instance, sir.
Yes, it is the instance of the module. It is the instance of the module. So module is just like a map. Let's assume you have a map. You have a map on the actual paper. Okay, and when you want to build a house, you can create many houses of the same map. So if you look at the map, let's assume if the map is drawn on a paper, on a sheet of paper. So this is a module template. This is a map template. And when you create the house, when you build the house from that map, what is that house called? It is actually the instance of that map. Okay, so if you look at this code, how many instances have been created? How many instances have been created?
4.
4 instances has been created. Okay, so this is the instance. Okay, it's also the instance of a module, and it's actually the object. How many objects have been created? So instance or and how many instances have been created in this example?
4, sir.
4 instances. So this is instance 2. This one, if you look at the yellow color, my add 3, it is the third instance. And if you look at the port list is different. Each module has its own port list. If you look at the port list, actually in the first instance and the first parameter, it is A0. Similarly, the second parameter list is B0. The third parameter is CN and S0. So it means that now we have created 4 instances of the module full adder, and this is called as module instantiation. Module instantiation. Okay. So there is a difference between module invocation. We can also call it module invocation or instantiation. So a module is invoked in Verilog. A module is invoked in Verilog. So we invoke a module in Verilog. Number 1, an object is formed. An object is created. thing, an object is created. Okay, what will be synthesized in hardware? If you look from the hardware perspective, what will be synthesized in hardware? Synthesize.
Adder.
No, if you look at the lower level, some synthesized. So it means that actually hardware will be created. So synthesize means that hardware will be created. Hardware will be created. Okay, when a hardware will be created. So in terms of what? Hardware will be created. Hardware will be created in terms of what? Very good. In terms of gates. And if you look at the more down to the abstraction level in a more detail, so it means what will be formed in hardware?
Transistors.
Transistors, yes. Yes, transistors will be formed. So transistor will be formed. Okay. Okay. And actually, if you look at the module, so when the modules are connected, when one module is connected with another module is connected with another module, so the modules are connected. And actually, if there are some gates in one module and some gates in another module and they are connected together, so actually it will create a complete hardware. Complete hardware. Now I will just explain this with an example. Let's assume we have two modules. Okay, let's assume we have two modules. This is module 1. Let's assume this is module 1. Okay, and now let's assume we have module 2. Okay, so these are two different modules. These are two different modules. The first one is module 1. And the second one is module. So now there are two different modules, and let's assume this is module internal. This is module internal. This is, let's assume this one is, let's assume we have A, we have B, we have here C, and we have, let's assume module output is K. Let's assume this module internal in the module internal is L. This is M, and this is N. If you look at the port list of module 2, how many ports are there for module 2? How many ports are there?
3.
Anybody? 3. What are the input ports?
L and M.
LM
L and M. And what is the output port?
answer.
N. Okay. So it means that the output of module 1, that is K, is connected to the input of module 2, that is L. Am I right or not?
Yes.
Okay, so if you look at the module, and if let's assume if we connect them in a module, how would you do this? So actually, so I can call it as a top module. Okay, so now let's assume this is my top module. This is my top module. This is my top module. Okay, and the input to this module is Y, Z, W, and the output of this module is P and Q. Okay, and now let's assume we have module template. If let's assume we have module template of this, let's assume we have module template. Now we are not going to the internet detail of module. We have some module template. Module 1. So actually, if you look at the module template 1, so the module template module. So it is our keyword. It's module 1. Okay. So the input is A, B, C, ABC. Module template for module 1. Okay. This is the template for module 1. Okay. So what should be template for module 2? Let's assume the template for module 2 looks like
mod
this.
2 LMN.
Let's assume module, this is the template for module 2. We are not going into the internal detail. We are not going to look at the internal detail, how the internal will look like, but just we are looking from the external. What is L, M,
And
N? So these are the modules. Okay. So now let's assume if we want to instantiate this top module. So now we want to instantiate this top module. This is your top module. And I want to create instances of module 1 and instances of module 2. I want to create 2 instances. One instance of module 1 and one instance of module 2. How would I write the code for this? Can anybody
mod
guide me?
1. Mod 1.
No. That's for the top level. Now, because now we are module 1. Module. It is our top module. The name of the module is top. Module top. How will it look like internally? Y, Z, W, Q. Am I right or not? Am I right?
Right. Yes, sir.
Yes, sir.
Okay. So now, is your what do you know? What is input? Y, Z,
Y,
W.
Z, W, sir.
What is your output?
P and Q.
PQ.
P and Q.
Output is P and Q. Okay.
Yes, sir.
So, right, output is P and K. Okay. Now we want to instantiate 2 instances. 2 instances. What is the name of in that instances?
Mod 1 and mod 2.
Mod 1 and mod 2. How can I create? First, you have to write the name of the module. What is the name of the module?
Top.
Mod
top,
1.
sir.
Mod 1.
Mod 1. Yes, right. This is the name of the module. So if you look at mod 1, that's the name of the module, and my mod 1, it's okay. What is my mod 1? What is my mod 1?
Instance of module mod 1.
No. Sorry.
Object.
No. My mod 1, if you look at my mod 1 is the name of the module. Name of the module. This is the name of the module. If you look at this mod 1 is the name of the module. And my mod 1, what is my mod 1?
Instance.
Yes, it is an instance.
सर यही बोला था ना अभी.
Man, I asked you a question. My mod 1. You told me that
Sir,
mod 1 is an instance.
सर आपने my mod
नहीं,
1
हम my mod 1 का कह रहे थे.
Okay, my mod 1 is actually the instance, and mod 1 is actually the name of the module. Okay, maybe I'm wrong. Okay, so now my mod 1. Now what you want to do? You want to connect Y with A. So what should be the first parameter of mod 1?
Y, Z.
Y. Z is connected with B.
Yes.
And then
W.
and W.
And then the
What about the
output. P.
Then we can create another module, mod 2. What is mod 2? Mod 2 is the name of the module 2.
Yes.
And then you give an instance name, my mod 2. Okay. What is the input?
L.
Not L.
नहीं, not L.
E and W. Sir P.
सर यहाँ पे वायर नहीं आनी चाहिए.
Yes, you need a wire. So, okay, now
Sir, L
my
तो
mod
P
1,
से भी
why is
connected है.
No. Okay, so L is connected with
P.
what's the output? Output is K. Okay, so now we have to say what is your output? Okay, now there are 4 parameters to module 1. What is A, B, C, and K is connected with P, and P is actually your output. Now, if you look at here, the output P Okay. P is connected with L. P is connected with L. P. You don't need a wire. P. M is connected with W. M is connected with W. And then your output N is connected with Q. So now this is the overall output. So if you look at this, then my mod 2. So mod 2 is actually the name of the module, and my mod 2 is the instance of module. And actually you create. So if you look at this, my mod 2. Now let's have a look at this my mod 2. It is an instance of mod 2. And actually hardware is created. What hardware is created for this my mod 2? What hardware is created?
Gates.
Hardware is created. What is the name of that gate?
Zor, sir.
XOR gate.
Yes. So hardware is created, and actually XOR is created. So I just want to give you a complete overview of that. So if you look at this full adder, so we have defined a full adder. It is actually the name of the module. My add1 is actually the name of the instance. And how many objects have been created? 4 objects have been created for module template full add in this particular example. And each object has its own IO interface. For instance, the first object that is named my add1 has its own IO interface, and the IO interface is A0, B0, Cin, S0, and C1. If you look at the instance name my add2, it is also different IO interface, namely A1, B1, C1, S1, and C2, and so forth. So okay,
सर
you got the point?
सर जैसे
Yes.
सर अगर हमारे पास गेट्स के 2 पोर्ट्स जो हैं वो अगर शॉर्ट हैं आपस में, तो हम लोग जो आउटपुट वाली पिन्स हैं उसको 2 टाइम्स लिखेंगे या एक ही दफा लिख लेंगे?
शॉर्ट की बात है, शॉर्ट नहीं है. You will not call it short. You will call it connected. If you're connected,
जी connected, if they are
you can use
connected,
the same name. Yes,
same
you can
name.
use the same name.
Only
Yes.
one?
like if you look at this example, like I will give you this an example. Let's assume this K, the output K is connected with P. So they are connected, so you can use the same name P. Okay?
सर P 2 दफा लिखेंगे एक दफा?
P, it's up to you. If you want to redefine a wire and you can connect a wire with P, it's up to you. But it's a very short code, because what you are doing, you're connecting K with P and you're connecting P with L. So if you look at the code, it's pretty much fine. You got my point?
Okay.
Okay, we'll elaborate it further by definition of ports. So when we will call it ports, so we will explain it in the upcoming example. What is ports? What is port? So ports.
Input and outputs of a module.
Yes. So what is port? Actually, port provide an interface. Port provide an interface by which a module can communicate with its environment. So these are the interfaces. I'll always give you an example of a car. What are the interfaces to the car? I explained it. Okay, the gear is the interface for the car. The steering is the interface to the car. Similarly, ports are interface to a module in which and it is used to connect different modules. It can be used to connect different modules. Okay, if you look at a chip, if you look at a particular chip, maybe any kind of a chip, like a microprocessor chip, you have also some ports. There are some input ports and there are also some output ports. Okay, so each module has some input port and output port, and the internal of the module is not visible to its environment. What is in internal? So if you look at the port, so let's assume if I'm looking at this my mod 1 and my mod 2. So can I see the internal of my mod 1 from this top module? Can I see
Yes,
what is
sir.
internal?
No, sir.
No. From this code, I cannot see that what's the internal. But if I look at the actual code of this my module 1 and in internal my module and module, I cannot see that what's the internal of the module 1. How many gates are there? So if you look at this mod 1, so there are 3 gates, 2 AND gates and 1 OR gate. And if I look at my mod 2, so actually it consists of only a single gate. But looking at this code in the module top, when I have used the name of the module and the instances of the module, so in this particular scenario, the internal of the module is not visible to me. Let's assume that if you have a brake system and if you have steering system, the internal of the engine is not visible to the user. Similarly, if you're instantiating a module, so the internal of the module, how the module is implemented internally is not visible at that time. Okay, you can look at the module definition at that time, and you can look at the internal of the module definition, and you can see that okay, what is the internal of module of the module. So if you look at this module, let's assume if you look module 2, if you look at the definition, it will in module, it will look like the internal module will look like this. XOR user output. What is your output? Q. What is your input? Not Q. N. N is your output. What is L and M is your input. So this is the inter. And then you also have to write. Please turn off your microphone, beta. Please turn off your microphone. Okay. So the internal of the module is visible. Okay. So now let's assume if you look at this module, if you look at the module adder, if you look at this module, so actually it shows the block diagram or the module for a 32-bit adder. How many gates are there inside the adder? It's hidden. How many gates are there? We don't know that how many gates are there. The internal is hidden. But how can you interact with this module? How can you interact with this module adder? Anybody?
Using the
ports
ports.
के through.
Using ports.
Using ports.
And what are the ports in this particular example?
A, B, C.
A, B,
A, B, C in, some and C out. Yes. Okay. So these are the ports, and actually you can interact with this module internal through its port. Okay. If you look at the adder, so the adder can be implemented using ripple carry adder. Ripple carry adder is a different implementation of the adder. It can be implemented using carry look ahead adder, or carry sum adder, or Manchester adder. There are different type of adder. I'm not going into detail into this type of adder, but the internal of these modules may be different. In digital logic design, you have studied different architectures of adder. One is a carry look ahead adder, and one is a ripple carry adder. So the adder implementation is not visible to you. You can also implement a logical function using different function. You can use a sum of product terms, and you can use also product of sum terms. Did you remember this?
Yes, sir.
Yes, sir.
Okay, so you can implement the same function. The function is same, the functionality is same, but the internal implementation of the function is different. It varies. How do you implement your functionality, or how do you implement your truth table? You have studied this in more detail in your digital logic design course. Okay, now what is port declaration? Okay, so now we look at the port declaration. All ports in the list of port must be declared as follows. So what are the keywords for the ports? As far as now we have studied input ports and output ports. There is always one port that is called as in-out. In-out means bidirectional port. In-output is a bidirectional port. It can be used either as an input port, or it can either be used as an output port. Okay. So it's for the bidirectional port. Okay. So it's the direction of the signal. Okay. So port connection rules. We can visualize a port consisting of two units. One unit that is internal to the module and other unit that is external to the module. One unit that is internal to the module and one unit that is external to the module. I will give this with an example of this module, module mod 1. What is the internal to the module Y? Module 1 for the signal A. What is internal to the module for a signal A? Anybody?
सर समझ नहीं आई.
If you look at module 1 in this particular zone, can you see the schematic? Can you see the schematic better?
Yes sir. Yes.
Yes,
Okay.
sir.
Okay. If you look at this module mod 1, this A is actually module internal. This A is module internal. And we are connecting this A with Y. So what is now Y?
External.
Module external. बेटा समझ आ रही या नहीं समझ आ रही?
Yes sir.
Yes, sir.
Okay, so actually now there are two different things. One is module definition and one is module instantiation. So if you look at this, module instant, it is module definition or module instantiation?
Definition.
But very good, very good. So it is module definition, very good. So it is module definition. And if you look at this my mod 1 and mod 1, what is this?
Is instantiation.
Instantiation.
Very good. So it is module instantiation. It is very good. It is module instantiation. We also call as module invocation. Module instantiation or module invocation, in which an object is created of a particular type. So if we're thinking from the port connection rules, from the port connection perspective, so A, B, C, and K, they are module internal or external? If you look at the module definition,
Module internal.
this is module internal. So this is module internal. And we are connecting this module internal with the module external. And what is now external in this module invocation? What is the module external? Can you
YCW, sir.
Very good. So these are module external. Very good. Very good. You're taking interest, and it's, I'm really very much excited that you're taking interest. Very good. So it's module external. So now what you are doing, you are connecting a module external with the module internal. The module internal is defined within a module definition, and module external is invoked through module instantiation. Am I right or not?
Yes, sir.
Yes, sir. Right.
Okay. Okay. Now, if you look at here, now there are two different things of a module. Let's assume this is any kind of a module, any module. So this is any module. You must remember these port connection rules. You must remember these port connection rules. Okay. So how many type of ports are there? Can anybody let me know? How many types of ports are there? We studied
Two
three
types.
types of ports. No, three types. Three types.
Input, output, in-out.
Yes, there are three types of ports: input port, output port, and in-out ports. So if we look at the module external, I'm redrawing it for the sake of explanation. So now this is your input. This is your output. And now this signal is your so this is module internal. Okay, if I'm if I'm saying module internal, it should be within a module definition or module instantiation.
Definition.
Definition.
Module definition. So now let's assume, just give any name to this module. Any. So we give a very simple name to this module. So let's assume, just give a name. Paste it here. So let's assume this is a module definition, my module logic. A, B, C, D. Okay. And and we are defining input A, comma B, output C, and in out D. So it means, and then there is n module also. We also have an n module here, and then this is module internal, and now we are not discussing the module internally. Okay, so now we can extend this. I can extend it here until here. So let's resume A. Now this is module A. Now D. And module. We are not highlighting that what's the internal to the module. So if you look at this code, the module internal. If you look at the module internal, so this A or B are input ports. Am I right or not?
Right, sir.
Okay. And what about C? Output. Output put. And D?
In-out.
In-out port. So now this is module definition. Okay. So this is also some internal implementation of the module, but I'm not going into detail in this. There are some gates, but I'm not showing these details. Now we are only explaining the port connection rule. Okay. So this is, so the above module logic. What is this? This is module definition or module instantiation?
Definition.
Module. Very good. Module definition. And due to this reason, are these four signals A, B, and C, D, they are module internal or external?
Internal.
Module internal force. Okay. Now look from the outside world. Now we want to connect something with this input and output or something like this. So it means now we have some module external. Okay, is there any eraser? Yes. Module external. Now these are module external. Now let's assume we want to instantiate this module. We want to instantiate this module. How can I instantiate module? Can anybody help me? How can I instantiate
Logic my
logic?
mod.
Very good. Logic. My logic. You can give any name.
Any name, yeah.
Yes, you can give any name. You can also give your name. What's your name?
Asad.
Okay. You can also give your name, Asad. I just for so it's up to you. Logic, Asad. And
सर जो भी हमारे input के नाम हो गए external.
External. So let's assume I'm using K, M, P, and Q. Okay, so it means that K is connected with which signal?
A, sir.
Hmm?
A.
K is connected with A. What about M?
B.
M.
B. What about E?
C. Output.
C. Okay. And what about D, Q?
Yeah. Okay.
So by this, okay, now I'm again repeating just for. So now this is module definition or module invocation?
Invocation, sir.
Invocation, sir.
Module invocation or instantiation. You can also call it instantiation. So this is module instantiation. Okay, now these signals K, M, and P, these are module external or internal?
External.
So module external. Now look at the rules. Now what are the rules? And you should and must remember these rules. So if you look at the rules on the left hand side, so the input and this input should be of type what? What should be the type of input?
Reg and net.
No. Input on the left hand side. Can you see on the left hand side in this purple circle? What should be the type of input?
So net.
Yes, it should be of type net. It must be of type net. And by default, input is of type net. Okay, what about output? Output can be what? If you look at this green circle,
So net or
Uh,
reg.
reg or net,
Reg or net, sir.
reg or net. So this output should be reg or net. What about in out? What about in out?
Net, sir.
Internal.
Net.
Huh?
Net.
In out should also be of type. Now we are talking about module internal or module external.
External.
No,
Internal, sir. Internal की बात कर
we
रहे
are talking about module inside the module or outside the module.
Inside.
Inside.
So inside.
Inside. When we are talking about inside the module, how it can be module external? Whenever you are talking about, then there are two things. I already explained it. I explained it so many times that there is one module internal that is internal to the module, and what is module external that is external to the module. Okay. What about K and B? K and B is module internal or external?
So external.
External, sir.
No, it should not be. Sorry, I'm very sorry. It's not B. It should not be B. It's M.
Should be M.
It should be M. Okay. What about K and M?
Module external, sir. External, sir.
External. When you talk about module external, what is this K and M? This K and M should be of what type?
Reg or net दोनों.
It can be reg or what should be the type of Q?
Net.
It should be net. What should be the type of P?
Net.
It should always be net. And if you violate the port connection rule, Verilog will give an error. Verilog will give an error. I will explain this to the example. One thing is very important. One thing is very much you must remember. Input and output are by default as net. Input and output are always by default as net. You got my point or not?
Yes, sir.
Yes, sir.
Until you redefine it. Okay. Okay. So whenever you want to use or instantiate or define a module, you must remember the port connection rule. Okay. What about input port? So let me explain it further. Internally, input ports are always of type net. Internally, input ports are always of type net. Okay. Externally, the input can be connected to a variable that is reg or net. So this is just the explanation of this above. This is port connection rules. Similarly, output. Internally, output can be of type reg or net, as in this output, reg or net. Externally, output would always be connected to a net. It should not be net. And similarly, the rule for in-out is always there, that it should always be of type net. I will now give you an example. What Verilog will give an error? Now let's assume that we have this module definition. We have this module definition. Then I write a code like this. Module logic input AB, output C, in output D. If I define reg A, what will happen? Reg A.
Error देगा
Why error?
because inputs are only net internally.
Input can all be net because reg A will give an error. Will give us an error, and the synthesizer will report that this A must be of type net. Okay. Okay. Now, if I'm right, reg C, is it legal or illegal?
It's legal, sir.
It's legal. Why it's legal? Because output can be reg. Output can be reg. Now, I will also give now another very good example that you can differentiate between it. What's the difference between reg or net? Okay. No, so I will give another example. A very small example. So let's assume we have module logic, input A, B, C, output C, output input module port rules. Okay. Output D, and these are some module internal. We are not going, and then it is in module. Okay. Output D, reg D. Okay, so if you look at this code, what is the type of A and B? A and B is
Net, sir.
of type
Net.
net. A and B is of type net because input and output are by default defined as net, of type net. Now, what is the type of C?
Net.
What is the type of C? C is of type. What is the type of D?
Register.
Yes, not register. Please don't confuse this with the register value. I told you reg is a data type. It stores a value until a new value is assigned. Okay. What is D? D is of type net or reg?
Reg, sir.
Why reg?
तो नीचे आपने बता दिया कि
Sir,
reg
assign
D
कर दिया इसको और D को.
Because we have
Reg.
redefined it. We have redefined it of type reg because it has been redefined. Okay, it has been redefined as reg. That's the reason that because it has been redefined as reg, that's the reason that is that the type of. So you must remember the port connection rules. You must remember the port connection rules. If I'm defining like this, reg A, what will happen?
Error, sir.
Error.
Sir,
Is
A
given
become reg.
error because the input port internally, not externally. I'm not talking about external. Because if you look at the port external can be reg. Can you see on the left hand side? बेटा नजर आ रहा है आपको या नहीं आ रहा? The port external can be reg, but the port internal cannot be reg. ठीक है? Okay. Now this is module definition or module instantiation?
Definition, sir.
Module definition, because it is module definition. Now let's say if you have a module instantiation, so now let's assume if I'm saying port rules because I'm now instantiating a module, port rules my rules. So now K, P, T, J. Now if you look at K, P, T, J, and now you have used it in another module. Okay. Now what you are doing? This is my module top, and this is some port list. I'm not saying there is some port list. Okay. Now this is end module. So module top. What I'm doing? So now this module top is a module definition or module instantiation.
Definition.
Definition.
This is module definition. And what about the port rules? This one?
Invocation.
Invocation or instantiation. So this is module invocation or module instantiation. Okay. Now if you look at the port rules, so if you look at the port rules, so what if you look at the port rules? So it means that the module external can be reg or net. So it means that this K and P can be reg or net. What about T and J? Look at this diagram. Look at the external output. What are the rules for the output?
Net.
Huh?
P net type.
It should be always of type net. Now, if I'm defining, if you look at this code, if I'm defining reg K, is it legal or illegal?
Legal, sir.
It's legal. And if I'm defining reg J, then
Illegal, sir.
Illegal, sir.